Good morning, everybody. We're about to start the webinar. We're going to give a few more minutes before we do that. Before we jump in, my name is Igor. I'm head of marketing at Circularise. Today, we're going to discuss blockchain technology to complement mass balance certification. The webinar is going to take up to 30 minutes. We're going to run through the slides, which should take anywhere between 15 to 20 minutes. And then we're going to have a Q&A session at the end of the webinar. The webinar is going to be recorded and shared with you afterwards. Now, before we jump into the content, there's a few things for you to know to get the most out of it. On the right bottom side of your screen, you can find a few tabs. On the very right side, the tab is called Chat. In the chat, you can engage with us, but at the same time with other participants. So feel free to introduce yourself, say who you are, where you're coming from, what do you do. Now, next to the chat button, you will see the questions. Please be mindful that if you want your questions to be answered at the end of the webinar, add them in the questions tab. The questions that will be added to the chat, we won't see them, we won't be able to prioritize them. So once again, if you really want, if you have an interesting question, if you want it to be answered, please add it to the questions bar. And also we're gonna run a few polls throughout the webinar. So would be great if you guys can also engage. Hi, Nitin. Hi, Paul. Good morning, everybody. Now, let's see. We're about 2.5 minutes in, so let's kick it off. The speaker of today is Mesbah Sabur. Mesbah is the founder of Circularise. He's built Circularise out of a master thesis at the Delft University of Technology. In the last few years, Mesbah, together with the team, scaled the company from 2 to 40 people at this point of time. And the core focus of Mesbah's work is working on the vision for the company, but also translating all the technical requirements into the actual product that we put on the market. Mesbah, off to you.
All right. Well, hello, everybody. As Igor mentioned, my name is Mesbah. I'm very happy to do this webinar and to start engaging with you guys after the few slides that I have prepared to talk about this, I think, extremely fascinating topic of how blockchain, which started as something that has nothing to do with supply chains, is actually fitting supply chains extremely well and bringing a lot of the benefits that we're going to discuss today. So yeah, let's kick it off and talk about a little bit of the agenda. So we're going to start talking about what we mean when we talk about mass balancing, and in particular, or more high level on chain of custody and traceability in general. And what are the challenges around mass balancing, and what can blockchain bring to the table? And what can maybe also blockchain not bring to the table? Because it's not a silver bullet, and blockchain will not solve all the problems in supply chains, right? All right, so just starting at a very high level, chain of custody is really all about understanding the sequence of custodianship, right? So who owned what at which time, at which sequence, and to be able to make some claim about it. Usually this is a claim about sustainability, right? So understanding the resources origin and provenance from raw material to final product and being able to sequence that. That's in general what chain of custody is about. And the reason we want to do this is because we're going to have some sort of a claim that we can use as the basis to then support any kind of certification or statement that we want to make at the end of the product's chain in the supply chain. There's many use cases to do this. There's many functions as a chain of custody can bring to the table. As I said, understanding the origin of the product, the sequence, and also ensuring that there is a somewhat of a link between the sustainability practice and the final product claim. And that's really where you come into different models. Also, more and more, we see chain of custody being used as the basis to then compile some sort of a life cycle assessment information to understand on a more primary data perspective what the product's lifecycle could be given this chain of custody. And this is all usually happening with third-party validators like certification bodies and auditors. to ensure the integrity and the final claim. Roughly, there's about 4 models. We could like do a whole PhD on this topic, right? There's many different things, but just keeping it simple, you can go from identity preservation to segregation, mass balancing, and certificate trading. And that spectrum, as you go from left to right, kind of decouples the claim itself from the product. On the far left, the claim and the product are identical. The claim you're making, let's say your claim is this is recycled material, then you're saying this product, this physical item, where the product or the claim is about, is actually recycled. Going more to the right, that claim can be decoupled. On certificate trading, that's like no real connection between the two, as far as where you can kind of start trading these credits. So we're going to talk about these things. It's good to keep in mind that as you go from left to right, the claim and the product itself, where the claim is about, are more and more decoupled. So with identity preservation, as the name suggests, like you imagine you have 2 streams, non-certified products and certified products. These are obviously separated, and between the certified products, there's also a separation between individual products and badges, etc. So like a total separation of any kind of documentation and claim and the product itself. There's no mixing whatsoever. Going into segregation, you already start to allow a little bit more of mixing, essentially. So let's take a certain product which is certified. You're fully segregating that from non-certified products, but within the stream of certified products within a similar type of attribute, you're allowed to mix. So a good example of this would be you're doing a certain type of bio-based feedstock, and you have a plant where you can treat all kinds of different feedstocks coming in and process them into outgoing products. You might have 2 separate units in that plant or 2 separate processing facilities, and you can certify them accordingly. One can be dedicated to only deal with the certified materials and the other with non-certified materials. Therefore, they're physically segregated and there's no mixing between the non and the certified material. But within the certified site, you're not really distinguishing between each incoming batch of product. Those can be mixed with each other. Going to the next model, which is the one that we're going to talk about today, you can see that mixing is allowed. So mass balancing specifically is much more about reconciliation of inputs and outputs on a higher level than on individual products, right? So you have mass balancing on batch level or site or multiple site, like group level. Today we're going to focus a little bit more on site and take it from there. But at the end of the day, it's all about making sure that even though you mix non-certified materials with certified materials, usually this is because the segregation is not economically possible, or the amount of non-certified materials is such a low quantity to start with that it just doesn't make sense, and it kind of has to be mixed initially. You can still guarantee that the overall proportion of certified material will be in balance in terms of input-output, right? And the main differences between different mass balance schemes is whether this mixing occurs and when it occurs, right? So, for example, in site level, as the name suggests, like site level mass balancing, you usually have a site, and within that site, you're allowed to mix all these non-certified as well as certified materials that come in, as long as you keep the balances of what came in, how much, in what proportion, and allocate them at the end of the day in the final end claim accordingly, and you never overclaim. And there's many different schemes that have different rules on when and how much, and all the different details there. And then last but not least is the certificate trading, what I mentioned, where you are allowed to kind of create almost this like trading platform of certificates. You should see this a lot with green energy, or with carbon credits for flights, where you can kind of offset it where there is essentially no connection between the physical activity and the sustainability claim, and they're totally decoupled. So moving on, and focusing in particular on mass balancing, there is a few challenges, and you can kind of translate them into opportunities at the same time that blockchain really brings to the table. And in particular, like in general, digital solutions, but in particular blockchain, especially about the first two. So one of them is the sensitivity of such a system, of a bookkeeping system, across a complex supply chains of many tiers of suppliers, of potential mistakes, errors, and even fraudulent actors, right? So that can be solved by using public blockchains to verify correctness of data. And we're going to talk about how that can happen in a second. And the other challenge is around complexity in supply chains and how it's really hard to scale a single solution across a global supply chain. And then the last point is really about automating a lot of the manual processes and making it as automatic of a transfer as possible. So starting with the first one, when it comes to these error prevention, you can think of a blockchain as a shared ledger, right? For those who are from the financial industry, and a ledger and should be a very basic concept where you just keep record of balances, essentially. And you could have, for example, if there's 3 sites, 3 actors, they could share a ledger, right? The balance of A, B, C is this at the first point of time. Then there is a edit in the ledger, and the balance of A becomes 50 more. The balance of B becomes 50 less. So there's essentially a transfer from B to A. And then the next phase, there is another transfer from A to C, where A's balance gets deducted 100 points, C's balance gets increased by 100 points. This is essentially what a blockchain does, right? So each instance represents a block in the chain, and they are connected over time, and there's logic between them, for example, about how these credits can be transferred, and you're not allowed to transfer them if you don't have them, for example, if your balance is less than what you want to transfer. So think of that as a simple blockchain, and it can be used to keep the balances, the credits, for example, in mass balancing. The nice thing is, however, that it's not just a single copy, because that wouldn't be very great. Like you could just have an Excel sheet where it's a single copy of it. The nice thing is that it's actually a copy that can be stored all around the world, right? Especially in the public blockchain, and anybody can keep a record or a copy of this ledger. And the way, and this is kind of coming to the clever mathematics of blockchains, this happens is that you can kind of keep each other in check, and there are economic and game theory incentives to make sure that the ledger always stays consistent. This is like the basis of things like Bitcoin, where you can run a Bitcoin node, basically keep a copy of the ledger, and everybody else is doing that as well. And through a consensus mechanism, any changes to the ledger are always done through a consensus protocol. And if you want to cheat the system, well, maybe you can on your own, but overall, the system will always take the favor of the one chain that is the furthest in their transactions, meaning that if you change something, you need to convince everybody else in the supply chain, or sorry, not in the supply chain, in the node, in the network, to also take your changes. And this means from a theoretical or a practical perspective, it becomes really, really hard to manipulate the data, because you have to kind of convince the whole system. And this kind of keeps the balances in check for everybody. This is very basic in terms of Bitcoin, because then it's usually about just a simple balance, and you're not allowed to send credits if you don't have them, or Bitcoins if you don't have them. But the thing that really made a leap in this technology was smart contracts that were introduced initially by Ethereum, because it kind of took that same principle of having a ledger and then putting them in a distributed way across the world, and anybody can run and verify the correctness of that data. but made it almost like general purpose. That's essentially what a smart contract is, right? So you make a piece of decentralized blockchain technology or blockchain logic or application in a very general purpose way. Like you could code some logic into it. Like if you send tokens, this is what you're allowed to do. If you receive them, this is what you're allowed to do. And because of that ability to add general purpose code to the blockchain, and then everybody would have to use that function as it is intended, it gives a huge amount of trust to whoever is running that code, and the way the code is done executed in a very, very transparent way. So translating to mass balancing, we could have smart contracts that have built-in rules around some of these rules and frameworks of mass balancing, for example, right? So you can build in double spend prevention, which is a basic concept for tokens, but also a basic concept required in bookkeeping for mass balancing. You could build in handling certain inputs and outputs materials according to your certification. And if you're not certified, you're not allowed to use those credits or not even receive those credits in the first place. And use correct conversion factors. Like if you're doing mass balancing in as a processor, and you receive some credits and you process them into another good, there is some yield, there is some losses in the process. You need to take those into account. And that logic and the exact ranges that you're allowed to use could be built into smart contracts. So by default, you're always using them and you cannot make a mistake. And you don't need to like audit them manually, because by definition, by using the blockchain and those smart contracts, you always do it accordingly. So for example, for double spend prevention, if you have a credit of value of 15 and you would send them to two different parties, currently like doing it in a manual Excel-based way and transferring the credits in a paper form, it's very complicated to audit, and a lot of manual steps need to be taken in order to prevent these kinds of activities from happening. And having that done on a ledger, like if you have 15 credits on a like a similar to Bitcoin, well, by design you cannot send it twice, right? Because if you could, you would be very rich if you can double spend the same Bitcoin. So this gives both the overall system a more like inherent trust by design, as opposed to trust by manual inspection and auditing afterwards, whether you didn't double spend those credits. The same would go for the other example I mentioned. Like if you are a manufacturer and you get a site certified according to all kinds of input materials that you're allowed to deal with, and what kind of system and claim, as well as what kind of a conversions you do to output materials, well, you could build this into your smart contract that you start with. So the auditor could issue the certification, gets translated into a smart contract, meaning that your account for that certified site can only receive these materials, and it can only manufacture and sell these materials. And outside of that, you're just not allowed to use them. And by design, using the logic on a smart contract, you will always follow those rules. So it just essentially means also less of a burden on the auditor side, because they audit the rules and put them in contracts, as opposed to audit whether the rules were followed afterwards, which is a lot less intensive. And then going to the second challenge around complexity. So most supply chains are extremely complex in that upstream there's raw materials that go into many different markets, like a certain type of plastics that could go into medical equipment, it could go into automotive, it could go into even consumer goods or textiles or what have you. But at the same time, all these markets like automotive is not only buying plastics, right? So from both sides of upstream as well as downstream, there's a lot of overlap into where materials come from. And there are many players who serve many different markets, meaning that if you want to have a closed system that all kind of certify and at scale have a lot of materials fully traceable, and it either works when there is a closed system, like one or two solutions that kind of rule everything, which is nearly impossible in the amount of complexity you have, or you work with an open infrastructure that is interoperable by design, and you don't have to worry about that problem of scaling it beyond borders and markets. And that's where we take inspiration from things like internet protocols and email, for example, where if you send an email to your supplier, you don't have to worry whether they use Gmail or Outlook or something else. It works because it's done using a shared protocol. And a similar thing can also be done on the side of traceability, where a shared public infrastructure is acting as a single source of truth. And you have one solution, let's say Circularise, you can have many different solutions tapping into the same protocol, and they could use that, and you don't have to worry about sending it to a client that doesn't use Circularise, for example. And then last but not least, it's this the challenge around it being time-consuming. In general, automating that, connected to a shared ledger or a single source of truth, if you will, could bring a huge amount of automation, both between credit transfers and balance keeping between suppliers and their customers, but also within a customer itself. You could do a lot of automation up to a point where it's like almost fully automatic, and the credits just travel along with the physical goods. We have conducted a pilot with the ISCC system, which is a leading mass balance certification scheme in plastics and chemicals and biofuels, with about 10 actors. And we have a short video to run about the project and what we did there. And then after the video, we can transition into the questions. So let's run the video.
Our planet is under pressure. Due to increasing consumerism and a linear economy based on take, make, dispose, climate change and resource shortages are soaring. The answer is moving to a circular economy. Together with these pioneering companies, we are driving change towards circularity. But how? Mass balance. Mass balance is a solution to facilitate the shift to gradually replace fossil materials with sustainable alternatives. This is how it works. The mass balance approach allows for the physical mixing of fossil and sustainable materials, while keeping track of the exact quantities. Although the actual quantity of sustainable molecules in a single product cannot be guaranteed, mass balance makes sure that the quantity of overall sustainable materials is directly reflected in the number of end products labeled as sustainable. In this innovative project, Circularise and partner companies worked with the certification scheme ISCC. Let's take a closer look at this example. Using Circularise's traceability software, partners could digitize sustainable materials and certificates and track sustainability credits along the entire value chain. Circularise's software helps companies to automate their bookkeeping process for ISCC Plus certification. Companies can easily book, allocate, and send sustainability credits. They can generate sustainability declarations in a few clicks, automatically create quarterly reports, and connect to other actors in the value chain. Consumers, on the other hand, can access sustainability data and certifications of the products they buy. With Circularise, they can trust sustainability claims of their favourite brands. Circularity is fundamentally a collective action. With the mass balance approach, we can inspire more companies to shift to sustainable materials and embrace circularity at scale. Do you want to make a real difference? Join us. Visit our website to explore more.
All right, Mesbah, thank you very much. We have just a few questions in the Q&A section. Everybody, if you still have questions after also watching this video, please feel free to add them directly in the question section. In the meantime, I'm gonna highlight some of the things that were asked there. Will the slides be shared afterwards? Samuel, we will not share the slides. However, we will share the recording of this webinar. Now, a few other questions. By Peter, do you have any incentivization to get agents to report correct data? Blockchain can make sure that data is not tampered with, but it cannot affect the original reporting. It's a very good question. Thanks, Peter.
Yeah, absolutely. Really good point. And this is also, as I mentioned in the beginning, blockchain cannot do everything. And it can definitely, the blockchain doesn't know what's happening in the physical world. Therefore, any data that you enter for the first time into the blockchain needs to be pre-vetted, right? That data can be wrong and the blockchain wouldn't know just by itself, right? So instead of thinking of the blockchain as something that will magically know and validate data itself, you can think of it more as something that will minimize the amount of validation needed. Because if you think of a supply chain, let's say there's 5 actors. If they all would use manual processes, at every step of the supply chain, something could go wrong with the data and could be manipulated, for example. But if they're using a shared ledger, at the first instance where the data is being entered into the system, yes, you could have, for example, the wrong values being entered, but that's where you need to double check and use validation methods like third-party auditors, essentially to make sure that that data is entered correctly. But once it's on the system, then the blockchain can take care of some of the logic, as I mentioned in the examples with smart contracts, that you don't have to check manually. So it minimizes the amount of data validation you need to do. It doesn't completely get rid of it.
Thanks for the answer, Mesbah. Just to play a little bit of that, once the data is in the system and it's audited, what is the data visibility among different stakeholders as it moves throughout the value chain?
Good question. So that's really where the design of the system can play a huge role in how that can be done. So if you're using a plain vanilla blockchain, smart, like a public one, anybody could see any data that you enter onto the smart contract, right? So it's public by design and anybody can see it. Obviously, in supply chains, this is not something that is desired for everybody to be able to just check anything that was entered into the system and to be able to analyze it. So we spent quite some years actually in the beginning of Circularise to research technologies how this can be solved. And one of them, which we have created, we call smart questioning, is a technology that makes sure that any data you enter into the system can remain hidden, but still you can validate the correctness of the data. It's a bit of a counterintuitive approach. It's using a new type of cryptography called zero-knowledge proofs, where you can prove the validity of data without showing the underlying data. So we can prove the validity of double spending or prove the validity of the underlying asset or a product that you're talking about on a public blockchain without showing the underlying data. So if you do it that way, then the amount of data that you can learn from the blockchain itself is nearly zero, or in most cases, it's just zero. And it's fully protecting confidentiality as well as bringing public validation of the data.
Thank you very much for the answer. One of the things that you just mentioned is the use of the public blockchain, and that's something that has been extensively covered in this presentation. Now, I see a few questions coming in on the energy consumption of a public blockchain. Could you speak on that a little bit?
Absolutely. It's a really good point, because it doesn't make sense to emit more energy using a blockchain that you're trying to save you getting a sustainable product being certified. Recently, about 3 or 4 weeks ago, the Ethereum blockchain, which is the blockchain we're using, moved away from the energy-intensive consensus mechanism called proof of work. This was the main reason it was using so much energy, because the way you could validate each other's blocks was by using a lot of computational power, which was just wasteful. And there's better technologies currently out there that can replace that. And it has replaced it in the case of Ethereum, which we've seen a reduction of 99.95% of a reduction in carbon emissions on the blockchain side itself. So this has already happened a couple of weeks ago, which is giving us already a huge amount of decrease in reduction and decrease in carbon emissions, which with this and with some other technologies that we are working on currently, the amount of energy we emit, we have done a study internally on the amount of energy we would emit in tracing 1 ton of PA66. And the amount of energy we would emit using a public blockchain is negligible. It's in the orders of less than 0.1% of the total savings that the certified material brings into the overall picture. So already is negligible. Looking at what we have upcoming in the technology with other reduction methodologies and the amount of energy even a public blockchain emits is going to be really negligible overall in the total energy sustainable materials can bring in savings.
In essence, if I understand it correctly, over the last few years, blockchain really took a leap, and what we're seeing now is the rapid decrease in the emissions that blockchain used to bring to the table. I'm going to pick the last question, and after that, unfortunately, we have to end. Is it possible to connect the mass balance calculations allocations with the company's ERP system to automate sustainability declaration creation?
Could you repeat that question, Igor? Sorry.
Sure. Is it possible to connect the mass balance calculations with the company's ERP systems to automate sustainability declaration creation?
Yeah, absolutely. So any technology nowadays, if it's like a modern software solution, you could have open APIs that you can connect to any kind of solution. A lot of the companies in supply chains use SAP or other similar ERP systems, which we can definitely connect into and automate all the processes. This is what I said, like for the last point, the potential is to really create a end-to-end mass balancing system, which requires like no human work whatsoever, from incoming credits to allocating them all the way to transferring to your clients, can be fully automated. Obviously, you do need to set it up and set up your settings essentially and requirements and the setup of the sites and the conversion factors. But once that's done, upon selling your credits, essentially you can press a button and the whole credit system will automatically be kept up to date in the background.
All right. Mesbah, thanks a lot for your time and for doing this. I would also like to thank all the participants and all the people who submitted the questions. It really helps us to keep this engaging. We will follow up with you with the recording of the video. At the same time, if you would like to learn more about the work that we do at Circularise, please go to our website, circularise.com, and reach out to our team. We're more than happy to discuss this with you. We'll also be at the K Show from the 19th to the 27th of October in Germany, in Düsseldorf, and we'll be at the Green Manufacturing Show from November 9th to November 10th. You can meet us there and meet our team face-to-face. On this note, once again, thank you very much for doing this, and we'll talk to you later.
Thanks, everybody.